Hello class, welcome to this video on 9.3 trigonometry. So today's essential question is how do we solve problems using trigonometric ratios and inverse trigonometric ratios for acute angles. All right, so this is officially the trig chapter or trig lesson, and we're going to go over some new trig functions that you may not have seen before. So the word trigonometry comes basically is a study of triangles. So you got trigon, which is triangle, and metron, which is measure. And usually you study right triangles, but it doesn't have to be right triangles, but for the most part it is. And you got something called a trigonometric ratio, which is a ratio of the lengths of two sides of a right triangle. You have sine, cosine, and tangent. So sine is opposite over hypotenuse, and the way we remember it usually is through SOHCAHTOA. Okay, so SOHCAHTOA, sine is opposite over hypotenuse. And you got cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Okay, so you got SOH, SOHCAHTOA. Okay, SOHCAHTOA, that's the mnemonic device in order to help us remember. Okay? All right, so we're going to show you what this looks like. So, for example, if I have this right triangle and I wanted to do the sine of, for example, A, well then the sine of A is opposite over hypotenuse. So this is the opposite side. This is the hypotenuse side. And then by default, this is the adjacent side. So if I wanted to do the sine of angle A, then it's going to be this side divided by this side. If I want to do the cosine of angle A, then it's going to be this side divided by that side, AH, right? Cosine, so ca. And then if I want to do the tangent of A, it's opposite over adjacent, TOA, okay? So that's kind of how it works. So let's look at some examples. So let's look at example 1. So find sine of J, cosine of J, tangent J, sine of K, cosine K, and tangent K. All right, so let's look at sine of J first. Okay, so you got sine of angle J. So this is angle J. So we want to do opposite. Remember SOHCAHTOA, right? So SOHCAHTOA. So sine is opposite over hypotenuse. So we got opposite of J is 5, right? And then hypotenuse is the longest side, which is 13. So we got sine of J is opposite over hypotenuse, or 5 over 13. All right, and if we do this calculation, we get about 0.38. Okay, and then we got cosine of J. So then again, it's going to be adjacent over hypotenuse. So it's going to be 12 over 13, which is equal to 0.92. And the tangent of J is opposite, which is 5, over adjacent, which is 12. And so that's going to give us 0.42. Okay, now let's look at angle K. So now this is angle K, and so opposite of angle K is 12. So now this time 12 is the opposite side. And then hypotenuse is still going to be 13, and then therefore the adjacent has to be 5 by default. All right, so we got sine is opposite 12 over hypotenuse 13, which is 0.92. Then we got cosine of K is 5 over 13, which is 0.38. Notice the switch between the value of sine K and cosine J. So the cosine J is equal to the sine K, and the sine J is equal to the cosine K. So let me put a little note here. So sine of J is equal to cosine of K and cosine of j is equal to sine of k. So I'm going to put that little note here for this example. This is always true for these types of examples. Cosine of one angle is always going to be the opposite. It's always going to be sine of the other angle in any triangle, in any right triangle. And then tangent k is opposite, which is 12, over adjacent, which is 5. So that's going to be 2.40. All right, so pause the video and see if you can try the following problem. All right, so we got sine of angle A. So we're looking at angle A. And then, so what is opposite? So remember, SOHCAHTOA. So sine is opposite over hypotenuse. So we got opposite of angle A is 16. Hypotenuse is the longest side, which is 20. And then we got adjacent, which is the other side by default. Okay, so we got sine is opposite over hypotenuse, so 16 over 20. Okay, so then when we do that, we get, well, that's also the same, that reduces to 4/5. And then, which is the same thing as 0.8. All right, so now we got cosine of A, so that's going to be adjacent over hypotenuse, so 12 over 20, which that reduces to 3/5, which is 0.6. We got tangent is, so we did cosine, now we're going to do tangent is opposite over adjacent. So opposite 16, adjacent 12. So that reduces to 4 over 3, which is 1.33. All right. Now let's do sine of C. So if you remember the trick, the cosine of A is the same thing as sine of C. The sine of A is the same thing as cosine of C. Remember we talked about that up here in this note, right? But so you can just say we know what the answer is going to be. But let me just kind of write down the adjacent, opposite, and all that stuff. Anyways, so we got cosine angle C. So let's do the opposite. Then we got hypotenuse. Then we got adjacent. All right, so the opposite is, or the sine is opposite over hypotenuse. So 12 over 20. Which we said was 0.6, 3/5 or 0.6, right? We got cosine of C, which is adjacent over hypotenuse, so 16 over 20, which is 4/5, which is 0.8. And then tangent of C, opposite over adjacent, so we got 12 over 16, which reduces to 3/4, which is 0.75. So another thing I want you to note is, like, if the tangent of J is always the flipped version of tangent of K. So that's another thing to note. So note the tangent of J is the flip of the tangent of K. Okay, so that's the same thing here, right? The tangent of A is the flip of the tangent of C in this case, right? All right, so we noted a couple patterns, and we can also use what we learned about special right triangles to find sine, cosine, and tangent. Okay, so let's say we wanted to do the sine of 60 degrees. So if we wanted to do the sine of 60 degrees, well, we're going to draw the 30, 60, 90 triangle. And remember that the 30, 60, 90 triangle, the sides are x, square root of 3, and 2x. Okay, now we want to do the sine of 60 degrees. So the sine of 60 degrees, remember, this is going to be opposite, and then this is going to be hypotenuse, right? And then this is going to be adjacent. So remember that sine, SOHCAHTOA. So sine is opposite over hypotenuse. So sine is going to be x square root of 3 over 2x, which is exactly what they got here. And then notice that the x's cancel. So let me get my pen here. Notice that the x's cancel, and that leaves you with square root of 3 over 2, which is approximately 0.87. All right, so let's look at another example here. Estimate measures by using trigonometry. All right, so Matthias builds a ramp so his sister can access the back door of their house. The 12-foot ramp to the house slopes upward from the ground at a 4-degree angle. What is the horizontal distance between the foot of the ramp and the house? What is the height of the ramp? Okay, so we got ourselves a right triangle. It's kind of hard to see here, so I'm going to draw it again here, all right? So we got this ramp. All right, and then this is at a right angle. And this right here is 4 degrees. And we got Y, we got X, and then we got, this is a 12-foot ramp. Okay, so that's what it looks like. So we got ourselves a right triangle, right? So so now we're going to say, what we're going to do is we are trying to solve for X, right? The height or the horizontal distance for the ramp. Okay, so that means if this is our 4-degree angle, if this is our 4-degree angle, then this is going to be opposite of that. This is going to be hypotenuse, and then this is going to be adjacent. So it looks like the best way to solve for X is to use adjacent and then hypotenuse, because we don't know what Y is, so we don't want to use that. So we're going to use X and 12. So that's going to be adjacent over hypotenuse. So if you remember your SOHCAHTOA, that sounds a lot like AH, adjacent hypotenuse, cosine. So that's why we're using the cosine, okay? So the cosine is adjacent or hypotenuse, which is going to be X over 12. And then the only way to get rid of that 12 is to multiply. So we're going to multiply by 12 on both sides. And so we get X is 12 cosine of 4 degrees. Now you can do this on any scientific calculator, okay? So for example, I'll show you on Desmos. All right, so here we go, we're on Desmos. And notice that when you hit that you have the cosine, sine, and tangent functions right here. So we're gonna do 12 cosine of 4 degrees, and we're gonna close the parentheses. Now you have to make sure that your calculator is in degree mode, because there's 2 modes. There's radian and then degrees. And look how it changes your answer. So if I change it to degrees, it changes it to that. So it makes a big difference. Make sure it's in degrees. So we have 12 cosine of 4 degrees. So it's going to be 11.97. Okay, so we're going to go ahead and put the answer here. So we got X was about 11.97. So this is the distance of the ramp. The length of the ramp is about 11.97 feet. All right, so the next thing is to find the height. So what is the height of the ramp? So if I go to the function, I can use opposite over hypotenuse. So that's O and H. But what is O and H, guys? Well, O and H is, let's go back up. Let's go here. O and H is sine. So we're going to use the sine. So sine is opposite of hypotenuse, which in this case is going to be Y over 12. I'm going to multiply by 12 on both sides. So this cancels. And then we're going to do 12 sine of 4 on the calculator to get 0.84. Okay, go ahead and pause the video and try the check. All right, so let's go ahead and do it. It says Mal changes the incline angle on his treadmill from 0 degrees to 5 degrees. So we got a treadmill where this is 5 degrees. If the walking surface of the treadmill is 5 feet long, how many inches did Mal raise the end of the treadmill? So how many inches is it going up? All right, so notice that this is 5 degrees. It looks like 50, so let me change that. So 5 degrees. Okay, so now this is opposite of that angle, right? So opposite, and this is hypotenuse. So which trig function has opposite and hypotenuse? Well, that's SOH. So that's going to be sine. So we're going to say, okay, sine of 5 degrees is equal to opposite over hypotenuse, so x over 5. And then we can multiply both sides by 5. So this cancels. So x is equal to 5 sine of 5 degrees. All right, and doing that on the calculator gives you 5.2. So you got about 5.2 inches. All right, so now let's look at inverse trigonometric ratios. All right, so inverse trig functions are basically the opposite of the sine, cosine, and tangent. Okay, so we call it the inverse, right? So it's sort of like the opposite operation. It's what cancels it out. Okay, so for example, we know that if I had x plus 5 equals 10, equals 9, then the only way to get rid of positive addition is by doing subtraction, right? If I had multiplication, well, the only way to undo multiplication is by doing division, right? So there's always an opposite operation. The opposite or the inverse of addition is subtraction, and the inverse of multiplication is division. Well, the same thing works with sine, okay? So if I have sine of A is equal to x, well then the only way to get rid of the sine is to do the sine inverse. Okay, so we're going to do the sine inverse, and it looks like a -1 there. It looks like an exponent, but it's not an exponent. It's to do the sine inverse, okay, the inverse sine. And that ends up canceling out the regular sine, see? And so you get that A is equal to inverse sine of x, all right? So that's just an example. So that's how you cancel out sine, is by doing the inverse. And the same thing with cosine. The way to cancel out cosine is to do the inverse. And this is located in Desmos as well. We'll show you that in a second when we do. And this is on all scientific calculators have these. Okay. All right, so example 4, finding angle measures by using the inverse. So the reason why the inverse function is useful is to help us find the angle. Okay, so here's an example. Use a calculator to find the measure of angle A to the nearest tenth. So here I want to get angle A, right? So this is the question mark. I need to figure out what that angle is. Well, okay, so if I'm looking at angle A, well then, okay, so this is opposite. This is so this is opposite. This is the hypotenuse of 15. And then this is adjacent. Okay, so clearly we have A and H, right? We don't have anything for O, so we can ignore O. So what's A and H? Well, remember, so ka toa, AH, ka, right? Cosine. So we're looking at a cosine. Okay, so we're going to say cosine of A is 3 over 15. So that's how they set that up. Cosine of A is 3 over 15, which is the same thing as 1/5. All right, and then how do we get rid of, so if cosine A is 1/5, how do we get rid of the cosine? Well, we got to do the inverse cosine of both sides. And so notice that these cancel, leaving me with angle A, the measure of angle A. When I do cosine of A, I really should be saying cosine of the measure of angle A. That's really what I should be saying. Is equal to the inverse cosine of 1/5. All right, and then we do that on the calculator, and we'll show you how to do this on Desmos. All right, so in order to do this, to do sine cosine inverse, you just go to function, and here you go. You got the regular sine cosine tangent, and then you got the inverse version. And so we're going to do the inverse. Okay, so we're going to do the inverse cosine of, then we go back to the main, 1/5, 1 divided by 5. And then we're going to do this, and then close parentheses. So inverse cosine of 1/5, 78.46 degrees. All right, so there we go. So we got our angle, and we want to round it to the nearest tenth, so 78.5 degrees. There's our answer. So that's what angle A is 78.5 degrees. Okay. All right, and so if we wanted to get angle B, then what we could do, they're not asking for angle B here, but if they are asking for angle B, well then now that we know angle A, by using the triangle angle sum theorem, we can get angle B. And so the angles have to add up to 180, and so then that will give us angle B. All right, so go ahead and pause the video and see if you can try the following problem. Okay, so let's go ahead and try this. So we got angle Z, and okay, so we want to find angle Z, right? So this is opposite, this is hypotenuse, this is adjacent. Oh, that's an AH. So that sounds like it sounds like that, right? AH, which is cosine. So cosine of the measure, cosine of the measure of angle Z is equal to adjacent over hypotenuse. And there you go. How do we get rid of the cosine? We have to do the inverse cosine on both sides. So this cancels, so we get the measure of angle Z equals the inverse cosine of 10/14. And we do this on the calculator, we get about 44.4 degrees. All right, so now we're going to look at solving right triangles, okay? So how do we solve a right triangle? Okay, we kind of already did this, so there's just a little bit more practice. So solving a right triangle means finding, you know, whatever angle or sides they want, right? So it says use a sign. It says solve the right triangle. So when they say solve the right triangle, what they really mean is find everything in the triangle, find all of the sides, find all of the angles, okay? So that they don't give you. All right, so let's figure out what angle R is first. If I want to get angle R, then notice that I got opposite and hypotenuse and adjacent, but we don't have adjacent, so I'm going to ignore that. All right, remember good old SOHCAHTOA. Which trig function do I have? Well, I got O and H, so that means I got sine. Okay, so we got sine is of R, sine of the measure of angle R is equal to opposite over hypotenuse, which is 6/9. The only way to get rid of sine is to do the sine inverse on both sides. And so then that cancels this out. So we get the measure of angle R equals the inverse sine of 6/9. And doing that on the calculator gives you about 41 point, hold on. This right here, when you cancel that, yes, you get 41.8 degrees for the angle. Okay, and then once we know that this is 41.8 degrees, then we can figure out what angle T is, because this adds up to 180. 180 minus 41.8 minus this 90-degree angle, okay? And so we get, when we do that, we get 48.2 degrees. All right, so let's plug in here. You can also do this by saying that R and T add up to 90. That works as well, okay? But either way, if you did the 180 or the 90 trick, you get the answer. So you get 48.2 degrees. Okay. All right. So now what we're going to do is, if we want to get this, let me call this x. So if we want to get that, we're going to use the Pythagorean theorem. So we're going to use this right triangle and use the Pythagorean theorem. Okay, so a squared plus b squared equals c squared. All right, so that's what we're going to do to get x. So we got x squared plus 6 squared equals 9 squared. Okay, so we got x squared plus 6 squared equals 9 squared. We got x squared, 6 times 6 is 36, 9 times 9 is 81. We're going to subtract 36 on both sides, and we get x is equal to the square root of 50 of 45. And don't forget, so this is going to be 45. And then don't forget to simplify the fraction, or the radical. So 5 times 9, and 9 breaks into 3 times 3. We can pull this pair out and kick it out. And so we get 3 square root 5. Okay, so this is 3 square root of 5, which is, as a decimal, is 6.7. And so we get our RS is 6.7. Okay, pause the video and see if you can solve the right triangle. All right, so since we got A is 62, we can find C, right? So 180 minus 90 minus 62, which is equal to 28 degrees. All right, now we're gonna do get AB. We're gonna find AB by using the 62 degree angle. So let's call this x and let's call this y. So let's solve for x, okay? So we got opposite over hypotenuse, and then we got adjacent here. So we got opposite, adjacent, and hypotenuse. So let's go ahead and solve for x. So that means if we want to solve for x, we need opposite and we need hypotenuse, okay? So which trig function has opposite and hypotenuse? Well, it's got to be this one, right? So sine. So we get sine of 62 degrees, that's this angle there, equals opposite over hypotenuse, x over 10 in this case. All right, get rid of that 10 by multiplying both sides by 10. And then do this on the calculator. 10 sine of 62 degrees is approximately, that's going to be 8.8. All right, so we got 8.8 approximately for BC. Okay, so now let's see if we can solve for y. To solve for y, we need to use A and H. So which one has AH? Cosine. All right, so cosine of 62 degrees equals A over H. Multiply both sides by 10 to get y is equal to 10 cosine of 62 degrees. Do that on the calculator. You get about 4.7. All right. So we're going to wrap this lesson up pretty soon. So the last thing is the idea of the unit circle. Okay, unit means 1. Okay, so unit circle means a circle of radius 1. Okay, so this circle has a radius of 1. The radius is the distance from the center to any point on the circle. Okay. So now if I notice that on this circle, I have a coordinate called xy. All right, so let me just put this a little darker. Well, it's kind of hard to see, so let me just leave it like that. So we got xy. And xy, notice that if I draw a line from there to there, that's the radius. And then these form a right triangle. So notice that if I use this angle right here, then this is going to be opposite over hypotenuse and then adjacent. All right, so let's say I call this angle, this is a Greek letter right now. This letter right here that you see is the Greek letter theta. Okay, so you see this letter here, that's the Greek letter theta. So usually in trigonometry we use theta for the angle. All right, so that's something that you haven't seen before, but now you'll start seeing it when you get more into mathematics and trigonometry. All right, so the sine of this angle is opposite over hypotenuse, right? So sine of theta is opposite over hypotenuse, which the opposite is the y coordinate, the hypotenuse is the r coordinate, the radius, sorry, y over r. And then cosine is adjacent over hypotenuse. Remember the SOHCAHTOA, so AH. And then the adjacent is the x coordinate, and the hypotenuse is the r, the radius. And so that's how they get these formulas, right? And then of course we could, solve for x and y by moving the r to the other side. And but in any case, this is how you would get that formula. So at the end of the day, what we realize is that for the unit circle, the x coordinate is always equal to cosine of the angle, and the y coordinate is equal to the sine of the angle. That's all you got to know at the end of the day, okay, for the unit circle. When you get into algebra 2, pre-calc, and things like that. In algebra 2, you used to do a lot of trig, but they moved that to pre-calc now. So if you get into that, you're going to be doing a lot of trig. But right now we're just doing kind of basic stuff. All right, so now this one says a point on the unit circle has coordinates given here. Find theta. Okay, so remember that a unit circle has a radius of 1. So here's the center of my circle, and this right here are the coordinates negative 0.5, negative 0.866. It's located right on my unit circle. So I go negative half here, so that means this is negative 0.5, or just 0.5 to the left. and then 0.855 down, right? So that's how I get there. But remember that this forms a right triangle. And the rate and the hypotenuse is the radius of the circle, which is just 1. All right, so now, and then this right here is my angle theta. So we'll call this theta. So how do I get the angle theta? Well, okay, so what's this right here is opposite, and this is adjacent. Okay, and this is hypotenuse right here. Okay, and so we know that the cosine of, or the sine of theta, or let's say cosine of theta, the cosine of theta is adjacent over hypotenuse, right? So ka toa. So a over h, which is 0.5 over 1. So basically cosine of theta is just 0.5, because 0.5 divided by 1 is 0.5. This is what we were talking about earlier with the unit circle, okay? All right, so now we're going to, the only way to get rid of the cosine is to do the inverse cosine. So that's how we get rid of this. So we get theta equals inverse cosine of 0.5, which you can do it on the calculator and get 60 degrees. All right, guys, that's going to do it for the video, and I hope you found this useful. And as usual, I'll see you in the next one.